Assalamualaikum warahmatullahi wabarakatuh. I am Abu Zarif and I am going to talk about Tealive Energy Management System Performance Review. So for the introduction, Tealive is working to cut energy use and be more efficient starting from 50,000 kilowatt hour in 2023, and the goal is to reduce by 40% down to 30,000 kilowatt hour by 2025. The plan includes like upgrade LED lights, better water pumps, and improvement to big energy use such as air conditioning and refrigerator. We are focusing on this part of energy plan because this is the most energy used in Tealive company. For executive summary, which is 20,000 kilowatt hour reduction. 2023 baseline is 50,000 kilowatt hour. For our target for 2025 is 30,000 kilowatt hour per year. This is a 20,000 kilowatt hour reduction, which is 40% of reduction. So for strategic wins, like I said, we use LED light, we implement the optimize the water pump and using energy saving refrigerator. So operational focus, we tightening control on big heater, which big heater means like air conditioner, refrigerator, so the biggest energy used in the company. Next, strategic commitment in minimizing impact via operational efficiency, like what I said before. We are using energy saving LED light, water pump, and optimizing refrigerator use. So with this commitment, it is complements with legal regulatory requirement and ISO 5001 standards. So our objective is reduce kilowatt hour and CO2 emission and maintain calibration logs conduct by annual management review. So our focus is production system building, like especially for electrical utilities. Like the refrigerator use, water pump use, and the out of scope is logistic, workshop, and vehicle fuel. This is the other scope, but it is implement for our energy saving commitment. So this is our organizational roles and responsibility. For me, Abu Zarif is outlet manager, and Nur Shazwani is facility supervisor, Yasmin as a barista, Exam as a technician, and Haikal as utilities operator. We all have our own roles and responsibility to make this program successfully.
Bismillahirrahmanirrahim. My name is Exam Nuruzuddin bin Awang. Next, this slide shows the CHUSUM analysis for performance monitoring. CHUSUM, or cumulative sum, is used to track the difference between expected and actual energy consumption over time. In this analysis, a downward trend indicates energy savings, while an upward trend indicates consumption or potential waste. On the chart, the x-axis represents the month, and the y-axis shows the cumulative deviation in kilowatt hours between the previous year and the current year. At the beginning of the period, we observed an early negative deviation of approximately 642.76 kilowatt hours, which indicates initial energy savings. This suggests that the early energy efficiency measures were effective. However, as the months progress, the CHUSUM line shows a consistent upward trend. This positive deviation indicates that actual energy consumption is gradually exceeding the expected baseline. This upward trend suggests operations drift, particularly within significant energy using systems, and highlight the need for stricter control and continuous monitoring. In conclusion, although the initial performance show promising savings, the overall upward trend indicates that target Corrective are required to sustain long-term energy efficiency. These interventions will be discussed in the following slides. Okay, we move to next slide. This slide shows the breakdown of our significant energy uses, or SEUs. As we can see, air conditioning is the largest energy consumer, accounting for 31.68% of total energy use. These highlights show critical HVAC systems to our overall energy performance. The second largest contributor is fridge and freezer systems at 20.06%. Together with air conditioning, these two systems make up more than 50% of the total energy consumption, making them our priority one energy uses. While they are essential for product quality, they are also highly energy intensive. Next, we have secondary loads, such as lighting at 10.55% and milk frauders and water handling, each contributing around 8 to 9%. These are classified as priority 2, where efficiency improvement can still deliver meaningful savings. Overall, the key takeaway is that energy reduction strategies should primarily focus on improving HVAC efficiency and refrigeration thermal management, as even small improvements in these areas can lead to significant energy savings. That's all from me. Thank you.
This slide shows the monthly electricity consumption trend. The usage fluctuates throughout the year, with higher consumption in February, August, and November, which indicated increased activity during these months. The R2 value of 0.89 shows a strong relationship between energy consumption and production output, meaning production is the main driver of electricity usage. This slide shows a deep dive into significant energy users, SEU, and their performance targets. For HVAC, energy use is mainly driven by ambient temperature, and the focus is on optimizing usage with an ENPI target of 0.86. The beverage chiller is driven by product volume, with temperature optimization giving the highest ENPI target of 0.93. For the tea brewer, staff demand is the main driver. Reducing idle time help improve efficiency, targeting 0.89. Lastly, lighting is also driven by staff demand, with the objective of switching to LED, achieving an ENPI target of 0.87. Overall, this target helps control energy by addressing specific operational drivers. These slides outline the critical operating parameter for key equipment to ensure efficient operation. Each equipment has a defined control parameter, target range, responsible person, and monitoring frequency. For example, the HVAC set point is maintained between 24 to 26 Celsius and checked daily, while the beverage chiller temperature is kept at 4 to 6 Celsius and monitored by technician. By controlling this parameter, we can prevent energy waste, ensure consistent performance, and support effective energy management.
Hi, my name is Yasmin Farzana and I will present about this slide. So this shows the instrumentation and measurement plan for Tealive energy management system. It explains how energy consumption is monitored to improve operational efficiency and support energy management from 2024 to 2025. The outlet is divided into three main areas: the counter, kitchen, and seating area. Currently, submeters are installed in the kitchen and for lighting in the seating area, which allows Tealive to monitor high energy equipment, highlight, and lighting usage separately. However, there are measurement gaps at the counter and some kitchen equipment, meaning not all energy consumption is fully tracked. This reduces the accuracy of energy performance analysis. To address this, The priority action is to install a dedicated submeter for the HVAC system, as it is one of the largest energy users. This will allow better monitoring and integration with the ENMS dashboard. As a secondary action, pressure sensors will be added to the water pump to detect leaks and cavitation, preventing unnecessary energy loss. Now, I will highlight Tealive compliance status, audit findings, and corrective actions under the energy management system. First, under the legal register, Tealive complies with the Efficient Management of Electrical Energy Regulations 2008 and aligns its practices with ISO 5001 Energy Management System standards. This ensures energy usage is managed systematically and meets regulatory requirements. Next, the table shows several non-conformities identified during audits. The first issue is the wastewater treatment. Operators were not adequately trained, so corrective training is scheduled to be completed by March 2025. The second non-conformity involved lighting sensors in the storage area not functioning properly. These will be replaced by April 2025 to avoid unnecessary energy consumption. Finally, there is a significant deviation where production line energy consumption is 23% higher than expected. This is treated as a critical issue and requires immediate root cause investigation. Overall, these audits help Tealive identify weaknesses, take corrective action, and continuously improve energy performance. This slide presents Tealive planned strategic capital investment to improve energy efficiency and reduce environmental impact from 2024 to 2025. The first initiative is the installation of an absorption chiller for the HVAC system planned for August 2024. This requires an investment of 15,000 and is expected to generate annual energy cost saving of around 1,152 with a carbon dioxide reduction of approximately 1.376 metric tons per year. The payback period is estimated at 2.5 years, which makes it economically feasible despite the high upfront costs. The second initiative is a refrigerant upgrade plan for June 2025, where the current R134A refrigerant will be replaced with R290. This upgrade improves environmental compliance by reducing global warming potential and supports more sustainable cooling operations. This timeline on the right shows the implementation milestones for both initiatives, ensuring systematic execution and performance tracking. Overall, these investments support Tealive long-term energy efficiency goals while balancing cost, payback, and environmental benefits. This initiative demonstrates how strategic investment can enhance energy performance while supporting sustainability.
Going to present about implemented energy conservation opportunities, which is ECOs. So first one, let's start with the energy conservation opportunities we have already implemented. The first one is variable speed drive on the tea brewer, which is installed in March 2024. This upgrade allows the brewer's motor to adjust speed based on the demand, cutting unnecessary idle consumption. So the second one is LED lighting retrofit. By replacing halogen bulbs with LEDs and adding motion sensors, we have achieved annual saving of RM293 ringgit and reduced CO2 emission by 0.35 metric tons. The payback period is just over a year, making this a highly cost-effective measure. So the third one is water pump optimization. Through pressure adjustment and leak repairs, we have improved reliability and achieved annual saving of RM40 ringgit. This initiative demonstrates how target action can deliver measurable financial and environmental benefit. Thank you. The second slide is competency and maintenance regimes. To sustain this movement, we have strengthened both staff competency and equipment maintenance. So for training framework, We have divided staff into two groups, which is influencers, managers and supervisor that are trained on ENMS, fundamental and energy performance indicators. Direct user, operators and maintenance staff receive hands-on training on significant energy uses and energy vigilance practices. So, for maintenance criteria, clear schedule are in place for HVAC, chillers, lighting and pumps. For example, HVAC system undergo monthly filter cleaning and refrigerant leak checks, while chillers are inspected for condenser efficiency. All activities are documented through SOPs and work instruction. This ensures that both people and equipment are aligned to maintain energy efficiency over the long term. For the slide 3, future outlook, the path to 2025. Looking ahead, our strategic target is to reduce energy consumption from a baseline of 50,000 kilowatt hours to 30,000 kilowatt hours, which is a 40% reduction. We will achieve this through two focus areas. Firstly, we will focus on design. Every new equipment purchase will follow energy efficiency principles. For example, procuring Energy Star laptop and IE3 motors ensure that efficiency is built into our operation from the start. The second one is culture. We are shifting from reactive correction to proactive prevention. Daily energy vigilance will become part of staff routines, embedding efficiency into our culture. So, in conclusion, by combining smart design with a strong energy conscious culture, we are confident in reaching our 2025 target and setting a benchmark for sustainable operation. Thank you.
In conclusion, this energy management study has successfully identified the significant energy uses within Tealive operation. Based on the analysis, refrigeration and air conditioning system are the major contributors to overall energy consumption. Energy performance indicators were established to ensure energy usage can be monitored and improved consistently. Several improvement opportunities have been implemented and further actions are planned focusing on better operational control, equipment efficiency, and staff awareness. With clear targets and structured action plans, the energy management system supports continuous improvement and aligns with ISO 5001 requirements, helping Tealive achieve more sustainable and efficient energy performance. Thank you.